Hi guys, my name is Shivani Chauhan and today I'm going to explain supply chain inventory management system which is based on linear programming optimization. And in this slide, I'm going to explain the agenda of my project. So this project mainly proposes an integrated supply chain inventory management system which is based on linear programming that's called LP. It's by using different method to optimize the inventory decision making at multi-channel networks. All system taxes such critical issues such as retailers, such as Walmart, such as Carrefour, and moreover, it provides optimization of stocks, determining the required quantity and strategic placement of warehouses, and also it representing the management of inventories of as and linear programming models. Furthermore, this project also reduced the total cost, keeping the constants of service levels. The solution giving practical solutions to demand projections, computing, and also in stock safety. Furthermore, optimization of distribution, the networks. This is a data-centric supply chain approach that can make supply chains more efficient, eliminate the holding cost, and it avoids the stockouts as well as optimize the entire functioning the dynamic retail settings. Well, in this slide, I wanna just provide you a little bit introduction about supply chain inventory management system. Inventory management of supply chain is an essential part of the retailing business which has a direct influence on profitability, customer satisfaction, and competitive edge. The contemporary retailer exhibit complex issues such as the dynamic nature of demand, storage capacity, supplies lead time, and cost pressure. The rule of thumb methods that were used traditionally do not work properly with large operations of thousands of SKUs and multiple locations. In here, linear programming offer a mathematical models behind the formulation of such complicated relations and finding the most optimal solutions. This will be aimed at reducing the overall cost, ordering cost, and holding cost. Moreover, it will also reduce the shortage cost and transportation cost as well. But also meeting demand and operational requirements. This project illustrates that facts that LP methods can turn inventory management into a productive strategic decision making process as opposed to a reactive process. In this slide, I want to provide you a literature view of my project. Like quantitative inventory management was established by a economical order quantity model that was formulated by a man known as Ford W. Harris in 1913. Moreover, later studies extrapolated the ideas to multi-challenge system, whereas inventory decision influence more than one stage of the supply chain. Shapiro in 2001 showed that the implementation of LP, like linear programming, is the design of a supply chain network, and Silver etc. al. in 2016 discussed the stochastic demand. The recent works of Nemias and Cheng in 2021 empathize the developed optimization method in the case of an omni-channel retail setting. McKinsey and Gatton industry reports have indicated the competitive edge that results in data-driven inventory optimization. Moreover, this body of literature makes linear programming an established strategy which is handling the complex inventory problems in the present day retail operation. In next slide, I'm going to explain some of the problems, statements, and objectives of my project. The major issue is selecting the best inventory policies in a retailing network, compromising the multiple warehouses and different products, distinct like demand patterns, the recorded quantities, order like reorder the points, safety stock levels, and warehouse to store allocation, the key variables of decisions. Example of the constraints are warehouse capacity, minimum order quantities required by suppliers, budget and service level requirements. The goal aims at reducing the overall expenses that include ordering expenses, for example, fixing expenses and per order. Moreover, holding expenses, it indicates the lockup insurance and shortage expenses that's also explained by lost sales, background fines, and transportation expenses. The aiming to maximize inventory turnover, minimizing the lead times, and being more accurate with regard to forecast is an all secondary objective. The solution should be scalable, able to respond to the fluctuations in the requirements, and be able to implement in real time operations conditions. So that's be more useful in it. In this slide, I will provide you the proposed solution overview. Like the solution proposed uses a three-phase architecture, and phase one consists of pre-processing of data, namely demand, forecasting with previous sales, cost parameters, estimates, and constant identifications. Phase 2 is develop the linear programming LP model, which has the following variable as the decision variable: order quantities, inventory levels, objective function, minimizing the total cost, and constant capacity, service level, budget. And in phase 3, takes action by coding up the solution in Python, and moreover by using the optimization libraries, that is also got PULP and SCPY, followed by the creation of actionable recommendations. Moreover, the system is integrated with the pre-existing ERP and inventory management systems via APIs to allow real-time updates. Furthermore, the inventory level, cost breakdown, and what if scenarios analysis are also visualized on the dashboard. Customization of to various products, line, and distribution channels can occur because of the modular architecture. Well, in this slide, I want to show you my block diagram. This block diagram shows how to supply chain inventory management system works end to end. We will start with collecting sales, product, cost, and capacity data. The data is processed through forecasting and validation, then fed into a linear programming engine that formulates and solves the optimization model. The results are analyzed for feasibility and sensitivity. The finally the system outputs optimal orders, quantity, reorders, points, and reports to support decision making. Well, in this slide, I'm going to explain my system flowchart. This flowchart shows the full process of inventory optimization. The system starts by loading historical data, forecasting demand, and calculating cost parameters. Then it formulates the objective constants before solving the linear programming models. If a feasible solution is found, the system extracts the optimal results, calculates the performance metrics, and generate reports and recommendations. Moreover, after sensitivity analysis, the solution is implemented and the inventory system is updated, followed by ongoing performance monitoring. That's all in this flowchart. Well, in this slide, you can show my algorithm and pseudocode. This slide outlines the algorithm used for inventory optimization. Moreover, this process begins by defining the inputs such as products, list, demand forecast, cost parameters, and system constraints. The model then initializes the optimization framework and set up decision variables for ordering and in holding and sortage. Next, the objective function is formulated and minimize the total cost. Constraints such as capacity, demand, satisfaction, and non-negativity are added. The linear programming model is then solved, and if the solution is feasible, the system extracts optimal orders, quantities, recommendations, inventory levels. Otherwise, parameters are adjusted and model is rerun. That's all in right. I'm going to explain the implementation of my project. The system was written in Python through Pulp Optimization Library, which has an interface and open source solvers such as CBC, a simulations case study of a retail networks that consider of 50 products, 5 warehouses, and many demand patterns that vary showed a significant improvement. The LP generated the best reorders quantities that minimize cost by 23% over the old rule based strategies. The management of stock level reduced the holding cost by 18% and there was a 95% service level maintained. The inventory turnover was also increased by 15 percent and which implies efficient role of capital. The average solution runtime of 2.3 seconds made it possible to support decision in real time. Uh, Moreover, in this slide, I'm not the sensitivity was used to determine the impact of cost parameters. Um, this was used during price negotiations with the suppliers. Next, in last slide, I wanna provide you the conclusion of my project. Uh, this project has managed to illustrate the effectiveness of linear programming as a tool used in the management of inventory in the supply chain. Moreover, in large-scale retail manufacturing, uh, the mathematical methodology offers objective data-driven decisions which are better than those which are based on intuition. Some of the major accomplishments are huge saving of cost and the delivery of the same quantity and quality of services. The moreover the applicability of the implementation in different retail cases and the possible to integrate with other systems in future directions. Machine learning can be used to improve demand forecasting and stochastic programming can be used to resolve uncertainly better multi-objective optimization to achieving a trade-off between competing the objectives and the integration of uh, time dependent decisions via dynamic programming. Moreover, the uh, framework offer a base of high-end supply chain analytical tools that will allow the retailer to ensure that keep ahead of their competitors through operational excellence and a high intricate panorama of their market. These are the some references of and thank you.